So welcome back. In this lecture I will be mostly discussing about the different classification of the thunderstorms and the typical hazards, weather hazards associated with the convective systems. So first group is classified as single cell storms. These are nothing but similar to ordinary thunderstorms. The life cycle of the ordinary thunderstorms we have already discussed in the previous lectures. So that means this type of ordinary single cell thunderstorm which lasts for about 1 hour, 1 to 2 hours. So they can created in a weakly sheared environment with a very less in conditional instability, and so that it will not last for longer time, and they can typically produce some kind of lightning, heavy rain, downburst and hails, such things like that. Another classification is the multi-cell storms. Multi-cell storms, as the name implies, they are not an individual storm. They comes in a group, so that each cell is having different passing through different life cycles. Some of the cells may be at the dissipating stage, some may be in the mature stage, another may be in between, and another may be in the cumulus stage, another may be in just genesis stage. So that all together the system will last for more than 6 to 12 hours, maybe sometimes more than 6 hours. So that after the dissipation of the one cell, another cell will come and give good rainfall, then which is followed by another cell. So that the system itself, altogether this multi-cell storms last for roughly more than 6 hours. And another classification is the squall line. Squall line, which in this radar, this is a typical radar image of radar reflectivity structure of a squall line, which looks like a high reflectivity of which is nothing but thunderstorms aligned along a line. It looks like a line. That is why it is known as squall line. It is associated with the squally wind also. And if you zoom this region, central portion, it will looks like this. So that means the radar reflectivity in the central portion of the region looks like a bow. That means there is a strong mesoscale downdraft which will be pushing this part of the cell to more towards the forward side of the storm movement, so that the entire the structure, radar reflectivity structure, looks like a bow. So that this type of bow feature in a radar reflectivity is known as bow echoes associated with the squall line. So then the more dangerous category of the thunderstorm is known as supercell storms. So this as the name implies, this is the strongest of the thunderstorms. So this generally forms in a highly wind sheared environment with a very high instability, in a very high unstable atmosphere, highly unstable, strongly sheared environment. This type of supercell storms will be forming. That means mostly the wind, the veering of wind, that means wind turning clockwise with the height is mostly favorable for this type of development of the squall lines. And these are mostly common in the middle latitudes. On this the main hazard associated with the supercell storms are tornadoes. So then is one more category of storm is known as mesoscale convective systems. As the name implies, this will be of the order of coming in the beta to alpha scale, like more than 200 to 600 kilometer length scale it is coming, and the typical lifetime is more than 6 to 12 hours to 18 hours, 6 to 12 hours, and sometimes exceeds 18 hours. So this type of feature is mostly evident in satellite observations and all. So because satellite observation covers a very large area, in satellite pictures, if you look at sometimes this type of mesoscale convective system, which are very common in the equatorial belt, in the tropical region. And how we define this mesoscale convective system is that the Maddox, maybe after the satellite in 1970s, 1980, Maddox proposed one objective criteria to identify this mesoscale convective system, which is nothing but, if you look at the IR imagery, satellite imagery, there is an inner cloud region in which the cloud top temperature is less than minus 52 degrees Celsius, which covers an area of almost like 50,000 square kilometers. So that is one criteria. Along with that, there will be another outer cloud ring region with the IR brightness temperature will be, the core cloud top temperature will be less than minus 32 degrees Celsius over a larger area of around 100 square kilometers. And this is not a circular form. This will be the eccentricity. Eccentricity of this shape will be should be more than 0.7 at the time of its maximum extent. These are the general criteria used to classify mesoscale convective complexes or tropical cloud clusters. So another main hazard associated with a thunderstorm is, the common thing is lightning. Lightning mostly produced in a bigger thunderstorms. So where inside thunderstorms you can have mixed hydrometeors, like existence of ice crystals, other solid precipitation particles like snows, graupel, along with cloud water and rainwater. So these ice crystals in this region, the turbulent motion, like upward and downdraft motion, makes lot of turbulence inside the clouds, so that there will be lot of energy separation happening by the collision of the ice crystals in between, so that the upper portion of the cloud will be getting a positively charged, and the lower part will negative charge will be accumulating. In response to that, there will lot positive charges develop in the ground, so that there will be a potential difference generated, and then finally the negative charge discharge through upward pointing objects like buildings, trees and all, so that then that forms a lightning current in the atmosphere, which will be visible as lightning, and after that we hear the thunder from this lightning. So this is the typical way of generation of the initially the negative charged particles, the negative charge will be coming down, which is in a stepped leader, and then the positively charged particle will be going up in the upward leader, so that the circuit completes, and then there will be a return stroke that is coming as the lightning strike towards the ground. So this is the very common. So this will last only for few microseconds. So in a matter of few microseconds all this happens. That if you look at the temperature of the heated air column during a lightning, it will be more than 20 to 30,000 degrees. So that in a matter of few microsecond, air will be heated in this much temperature, so that there will be lot of void region will be generated, and towards that air from outer region will be attracted. So that is heard as thunder. So that is because first lightning happens, after that after a few microseconds only thunder will be heard, and one reason is that light is traveling faster than sound. So that is why always thunder is following lightning. And then there are different type of lightning occurs in the cloud. Between clouds, that is known as intra-cloud lighting. If a cloud with a negatively charged particle accumulated in the bottom, and which is approaching coming to close to another cloud which is having positive charges on the side, so that the discharge happens not between cloud and ground, between these two clouds, that is known as intra-cloud lightning. And then another the normal type of lightning, that is from the cloud to ground, it is known as cloud to ground lightning. And another type of lightning within the cloud also, sometimes this positive and negative charge particle will discharge within the clouds, that is known as intercloud lightning. And so these are the different type of lightning in the atmosphere. So these are the seasonal distribution of lightning in the atmosphere over Indian region. If you look at the Indian region, we can see that there are two, especially over Kerala region, there are two prominent seasons of lightning. One in the pre-monsoon, that is this season, like in March, April, May season, we get normally lightning. This is the lightning image from detected on board TRMM satellites with detected using a lightning imaging sensor. So this is almost like the lightning flash rate is very high during March, April, May season, and then October, November, December. During monsoon season, we normally won't get much lightning. Instead, Orissa, extending from the monsoon rough region from Orissa to Rajasthan, we get along this Gangetic plain, we get good lightning activity during monsoon season. So then another type of hazard is the hail. Sometimes this is also common in the mid latitudes, maybe in the latitude above 30 degree north or south. So in a very big updraft thunderstorms, like supercell storms with updraft of the order of 40 to 50 meter per second, so that will sustain the ice crystals down inside the cloud to grow bigger and bigger, so that it will not come down due to intense updraft. So the ice crystal will grow in bigger and bigger size. Finally, which overcome the updraft, it will come down as this ice crystal, as ice. So that is known as hails. So sometimes in the tropical atmosphere, if you look at the cloud base below the region between the ground and the cloud base, that is known as subcloud layer. If that subcloud layer is warmer, then warmer also, and also not that much humid atmosphere. So normally in tropical region, this cloud, even though it is coming down in around 5 kilometer of the atmosphere, there is a melting layer, so that it will normally melted to liquid water before reaching the cloud base. And if some of the particles are large enough, then if the subcloud layer is dry and warmer, then the rest of the ice crystal will be melting below the cloud base, so that normally in the tropical atmosphere we won't see hails coming to the surface. But rarely there are hailstone events occurred even in Kerala also, reported in Kerala also. And otherwise this is very common in the mid latitudes, where subcloud layer is very thin and humid, and also there will be lot of updraft and wind shear supercell storms are present. So then comes another form of hazard is the tornadoes. This is very common, like twister cinema means film you might have seen. So that is tornadoes are twisters. So the formation of tornado happens within the supercell storm, so that we need a highly sheared environment. If you look at the wind shear in this type of atmosphere, where only wind speed is changing with height, but it means wind speed is increasing with height, but the direction remains constant, which will generate a shear vector in the same direction of the wind, and a vorticity vector opposite to that. That will generate kind of crosswise vorticity, and this in another type of sheared environment in which there will be the wind speed remains same, but wind direction changes with height. That is a varying atmosphere in which there will be a vorticity shear vector along this direction and vorticity vector generated along the mean wind direction, and there will be rolling vortices associated with that. So if this type of environment, if a thunderstorm pass through this type of environment, so what will happen is that this horizontally oriented vorticity structure, the vorticity vector will be tilted upwards, so that there will be rotating updraft generated inside the storms. So that is creating type of rotating updraft, which is the reason for twister or tornadoes. So that will suck most of the air from the bottom towards this center region. And also the direction of this, if you look at the direction of these two cells of rotation, one is clockwise, another, so that at the center there will be lot of void will be generated, so that there will be a localized low pressure region, so that will suck the air from downwards, so that the portion will extend up to, the cloud portion will looks like extending towards the ground, and the entire portion will be rotating upwards. So these are the type of rotating updraft, which is nothing but tornadoes. So if a tornado which is forming over ocean or water, so then instead of if there is object on the land, that will be also lifted up with a approaching tornado. So if there is no solid object, if it is forming over water or ocean, so instead of object it will lift the water, so that there will be a tunneling water tunnel found beneath the clouds, so that is known as water sports. So another is the dust devil, which is very common in the desert region, where there is no water vapor to condense. Instead of water vapor, the dust itself will be carried away upward in a very unstable atmosphere. That results into dust devil kind of thing. Then there is the convective activity over northeast India during pre-monsoon time, March, April, May season, is normally known as nor'westers. Locally it is known as Kal Baisakis. So why it is nor'westers is that it is moving from the northwest direction towards the Bengal region. That is why it is known as nor'westers. It is a kind of tornado type of supercell storms, which and this hail, the tornadoes are common in over those regions. Then another convective activity over northwest India, the dust devils, which is locally known as Andes in the northwest India, especially the Rajasthan desert region, where a lot of dust storms will be generated during pre-monsoon season. Instead of thunderstorm, dust storms will be generated. That is locally known as Andes. So another two main hazards associated with the thunderstorms are cloudburst and downburst. Cloudburst is nothing but heavy precipitation during a short period of time. Roughly, if you look at the IMD manuals, and it is like 10 centimeter rainfall happening in 1 hour, it is classified as cloudburst. Though there are another cloudburst classification nowadays coming up, like mini cloudburst, mesoscale cloudburst and all. So that is slightly different, but cloudburst generally the term used to classify type of rainfall happening within a short period of time, normally from a cumulonimbus cloud. Downburst is nothing but if there is a large scale downdraft, strong downdraft happening within the cloud. So then if a aircraft moves beneath that cloud, if downdraft happening, this aircraft will come and collide the ground. So that is another type of potential for the hazards associated with the clouds. So there are two type of downburst, microburst and macroburst. Microburst is nothing but if the area is less than 4 km, then it is known as a microburst, and if it is more than 4 km, it is known as a macroburst. So this is the typical image. So these are the typical type of cloud systems over world, over the classification of the clouds and main weather hazards associated with the convective systems.